Hello everyone. Today we are going to be covering section 4 of Unit 2 in Honors Algebra 1. So you should have out your interactive notebook. If you don't have it out, go ahead and pause this video, get it out. You're also going to need scissors and glue. You can get both of those things out. Once you have those, you can press play and resume the video. If you already have all those things out, we are going to go ahead and turn in our interactive notebooks to the next set of empty pages. So for me, that means that I am on page 26, and we are going to put a header on the top of our page. So right up here, we're going to write our unit dash section, so Unit 2, Section 4, and the title of this is Parallel and Perpendicular Lines. Now that we have the title there, we are going to flip back to our unit organizer and fill in our current section. So we are in section 2.4. That was parallel and perpendicular lines. And for me, that happens to be on page 26. You'll need to check yours to see what page number your section is beginning on. All right, I'm going to flip back to my page. First thing we're going to do now, you should have received a handout that has on one side perpendicular lines and parallel lines, and on the other side, the inside of this foldable with our dotted line on the outside that we're going to cut on, and then we have this black solid line that we're going to fold on. So once you have that totally cut out, should be trimmed down with this part also cut, and then those fold down to create our flaps. So now that we have this, there's one thing that we need to fix, because I just noticed as I'm recording this video that I accidentally flipped the parallel line and perpendicular lines sides on this foldable. So we are going to fix that real quick, and I'm actually going to grab my black ink pen and scribble across. This side is parallel lines, and that changes our image as well. Parallel lines are the ones that go like this, and then this side needs to be perpendicular lines. And we'll cross out that picture too. This should be your intersection with that 90-degree angle right there. And putting my arrows on my lines. All right. So now that we have these sorted, so we got parallel lines on the left, perpendicular lines on the right, we're going to open that flap for parallel lines, and we're going to start with those parallel lines. So parallel lines are lines that never intersect and have the same slope but different y-intercepts. An example of this, if we were to take our straight edge, which I didn't mention this earlier, but you might want a straight edge too, so I would grab a ruler. And if we were to draw a line that is passing from this point to this point right here. So that's -6 on the x-axis to -4 on the y-axis. Then you end up with this line right here. We've already talked about how to find slope. So we're going to emphasize our slope here. We went down until we get to a point that crosses directly on the grid, which the next one is actually this point right here. So we went down to get to that point, and we went to the right. And we're going to count those squares. So we went over 3, down 2. And now we are going to see, can you see that super well? Not really. I'm going to zoom in here so you can see a little better. Okay. So now we're going to draw another line that has the exact same slope. So I'm going to start by placing a point up here, and then I'm going to go down 2 and to the right, 1, 2, 3. And now I'm going to draw a line with a straight edge that crosses through those 2 points. And this should create a set of parallel lines. So again, we have that same slope where we went down 2 and to the right 3. Okay, so that's our definition of parallel lines. And here's our example of parallel lines. Now we're going to go further down in our foldable, and we have how to, and this how to would be to write an equation for a line that is parallel to another line. So to do this, we're going to write an equation in point slope form, which, remember, point slope form, that is y minus y1 is equal to m times x minus x1, using the point the line passes through. Then we're going to convert that equation to be slope-intercept form, or that is y equals mx plus b. So in our example here, we're going to write an equation for a line that is parallel to y equals 3x plus 2 that passes through the point 4, 5. So we get our slope from that first equation. That's our slope right there, that 3. And we have our x1, y1 from the point that we need to pass through. So that would be our x1, y1. So to solve this, we're going to start by plugging slope and this coordinate point into our point slope form. So I have y minus the y from the point we're passing through, which was 5, is equal to the slope, which we have from our initial equation up here, that's 3, times x minus our x from the point we're passing through is 4. So now we have y minus 5 is equal to 3 times x minus 4. Now that we have our setup for the equation, we are going to go ahead and find our equation by converting to slope-intercept form. First thing we need to do is distribute this 3 across both pieces here. So we have y minus 5 is equal to 3x, because 3 times x is 3x, and then 3 times -4 gives us -12. Now if we're trying to get y equals mx plus b, that means that we need to get y by itself. So we're going to go ahead and add 5 to each side to isolate our y. And that leaves us with the equation y equals 3x minus 7, because negative 12 plus 5 is equal to 7. And this right here is the equation for the line that is parallel to y equals 3x plus 2 that passes through the point 4, 5. Okay, so that's parallel lines. We're going to go ahead and close our parallel lines flap. And now we're going to go to perpendicular lines. So for perpendicular lines, we're going to open this flap again. We have lines that intersect at, that would be 90-degree angles and have negative reciprocal slopes. If you don't remember what a reciprocal is when you take a fraction, say 4/5. The reciprocal is when you flip that fraction so that the denominator becomes the numerator and the numerator becomes the denominator. So the negative reciprocal of this is going to be 5/4, and the word negative tells us that we need to have a negative, or we're taking the inverse of this as well. So if it was positive, now it's negative. So this is negative 5/4. Those are negative reciprocals. So now we're going to draw an example of this on the graph. So I'm going to start by drawing a line, and let's just start at this point right here, and I'm going to choose to go up 3/4, and that puts a point right there. So I'm going to connect those two lines with a point. So I'm actually using slopes of 3/4 here. And since this has a slope of 3/4, then I need a slope of -4/3 for my perpendicular line. So I'm going to pick this same point to cross through. And if I want a -4/3, then that means I'm going to go down 4, 1, 2, 3, 4, and to the right 3, 1, 2, 3. And that's my second point. So now we're going to go ahead and draw a line that passes through both of those points. And when I do, you should see that we end up with a 90-degree angle right here. So this 90-degree angle indicates that we have our two perpendicular lines. So now that we have our graphed example, this shows what those look like. We are now going to switch to finding an equation for a line that's perpendicular to another line that we already have. So to do this, we're going to first find the negative reciprocal of the slope, which again means you're going to flip the fraction and then negate it. Then step 2, write an equation in point slope form, which we just talked about. Point slope form would be the y minus y1 is equal to slope, which is m times x minus x1, and using the point that the line passes through and the negative reciprocal of slope. Once we have that equation, we're going to convert it to slope-intercept form, or that is y equals mx plus b. So in our example, we have write an equation for a line perpendicular to y equals 3x plus 2 that passes through the point 4, 5. So first thing that we're going to notice here is we have a slope right here of 3. So the negative reciprocal of slope is going to be the opposite of this. So 3 as a fraction is 3 over 1. So the negative reciprocal is 1 over 3. And this is positive. So our negative reciprocal is then negative. So now that we have our negative reciprocal of slope, and we also have our x1, y1. So this is our line that's perpendicular passing through this point. We're going to go ahead and plug those things into our point slope form. So I have y minus the y from the point we are passing through, which is 5, is equal to slope, which we have negative reciprocal of. So that's negative 1/3 times x minus the x from the point we're passing through, which is 4. Close your parentheses. Now we're going to go ahead and go to step 3. And we're going to convert this equation to y equals mx plus b. So first thing we're going to do is distribute that negative 1/3. So we end up with y minus 5 is equal to negative 1/3 x. Then we have a negative times a negative, which gives us a positive. And then 4 times 1/3 is 4/3. To get y by itself, we need to move this negative 5. We do that by doing the opposite operation. We're going to add 5 to each side. So we have y is equal to negative 1/3 x. Then we have 4/3 plus 5. We need to convert 5 to be in thirds in order to add these fractions. 5 times 3 is 15. So 5 is 15/3. So 15 plus 4 gives us 19, and we're still over 3. This equation right here is our equation for the line that is perpendicular to y equals 3x plus 2 and passes through the point 4, 5. Okay, so now that we have our foldable completed, we are going to take this, and I'm going to zoom back out so you can see my notebook page again, and we are going to glue this into the top of our first page. You can go ahead and pause this video while you are gluing this foldable into your notebook. Once you have your foldable glued into your notebook, you can go ahead and press play and restart this video. Okay. Next, you're going to take the half sheet of paper that you should have received. It should look something like this, where it says classify each of the following sets of lines as parallel, perpendicular, or neither. So now we're going to be working on this piece. I'm going to zoom in so that we kind of get one box at a time here. And I'm going to write on here before I glue it in. So for each of these, if we want to classify them as parallel, perpendicular, or neither, we need to find out if their slopes are going to be, for parallel, the same, for perpendicular, negative reciprocals, or for neither one of those things. So first thing I'm going to do here is I'm actually going to draw a small dotted line right where we have that word and. I'm going to solve for slope on the left for this equation and slope on the right for that equation. So for our equation on the left, we have 2x plus 10y equals 5. The easiest way to find slope here is to convert it to y equals mx plus b. So to do that, I need to subtract 2x from each side. That gives me 10y equals, you can either write this as 5 minus 2x, or you can rearrange it here and do negative 2x plus 5. To get y by itself, we're going to divide both sides by 10. And slope is going to be the value in front of our x-coordinate, which is negative 2 over 10. And that does actually reduce. Negative 2 over 10 is the same as negative 1 over 5. So our slope is negative 1 over 5. The second equation here we have y equals 5 times x minus 5. We're going to start by distributing this 5 here. Our goal again is for slope-intercept form. And when we do distribute the 5, we do get slope-intercept form, 5x minus 25. Slope for this equation is the 5 right there, so m equals 5. So now we have negative 1/5 and 5. Those are negative reciprocals of each other. So that means that these two equations are for perpendicular lines. And that's what we were looking for. Okay. Now we're going to go ahead and go to part B. If you would like to try any of these on your own, you can pause the video when you get to the equation, solve it on your own, and then press play to check your answer. So for part B, I'm again going to split our section, our space here. I have negative 5x equals y on the left, which means slope is just negative 5. On the right, we're going to need to do a little bit of solving to get this into slope-intercept form. I'm going to start by subtracting 25x from each side. That gives me 5y equals negative 25x plus 1. To get y by itself, I need to divide both sides by 5, which tells me that slope is going to be equal to negative 25 divided by 5, which happens to be negative 5. Since we have a slope of negative 5 and a slope of negative 5, that means that these two equations for the lines are parallel. These two lines have the same slope, but they have different y-intercepts. Okay. For part C, we are again going to draw a dotted line and split our space. On the left, we're going to start by rearranging to slope-intercept form. I'm going to subtract 6x from each side. So I have 3y is equal to negative 6x minus 9. To get y by itself, we are going to divide both sides by 3. My slope is then going to come from this negative 6 divided by 3. Negative 6 divided by 3 is equal to negative 2. Now we are on to our second equation, and we need to find slope here as well. So we're going to start by converting this to slope-intercept form. If you are really familiar with the point-slope form here, then you don't actually have to do that because you should already be able to see the slope. If you're not, then you're going to want to convert it. I initially said we're going to convert it, but we don't need to because our slope is actually right here. So our slope is 1/2. So now we have slope of 1/2 and slope of negative 2. Those two numbers are negative reciprocals of each other. So that means that these two lines are perpendicular. All right, on to part D. For D, we are going to again split our space. We have y equals 2x plus 6. When we have slope-intercept form given to us like that, automatically we know that slope is just 2. The second equation, we have y equals 1/2 x plus 3. So again, we already have our slope right there as 1/2. A slope of 2 and a slope of 1/2 are not the same. Neither are they negative reciprocals of each other. So that means that these two equations are neither parallel nor perpendicular. They're just two lines that will cross at one point somewhere on a graph. Okay, once we have that complete, I'm going to zoom back out so you can see my notebook page again. We are going to again glue this into our interactive notebook. So I'm going to flip this over and glue. You can go ahead and pause this video, glue your piece in, and once you have your page glued into your notebook, you can go ahead and press play and resume the video. On the next page here, we have one last thing to add to our interactive notebooks today, which is a word problem. So we have been trying to work on those word problems because, as you learned from that first test, we do have quite a few word problems that we are working with. So you should have received a printout. It's on a half sheet that looks like this. You're going to want to cut it down to size so that it will fit into the notebook nicely. I'm going to zoom in on it. We'll do some solving, and then we will glue this in afterward. So pause this video, trim it down to size. Once you have it done, go ahead and hit play. All right, we have on this problem, a farmer decides to use part of her land to generate solar energy. She plans on installing rows of solar panels either perpendicular to Meadowway or parallel to North Road. If the first row of panels starts at 4, 3, what equations would describe the two options for the row? Okay, so this is black and white here, so it's kind of hard to tell, but this is a picture of some solar panels in rows on in some farmland right there. This graph kind of helps us to see what we're looking at here. So we have Meadowway right here. We have North Road here. It said in our instructions that we want to be either perpendicular to Meadowway. So I'm going to underline that. Perpendicular to Meadowway. Or we need to be parallel to North Road. So I'm going to underline that part too. So we have perpendicular to Meadowway, parallel to North Road. I'm going to start solving using that first piece here, perpendicular to Meadowway. So if I take, I'm actually going to label down here that we're going perpendicular, and that would be to Meadowway. First thing I need to do is find out the slope of Meadowway. So I'm going to look for 2 points that cross directly on a grid line. It looks like I have one right here, and I also have one right here. So we went over 1, 2, 3, 4, 5 spaces, and we went up 1 space. So if we went up 1 over 5, that means that the slope of Meadowway is 1/5 because y's rise. Rise over run. The y, your vertical change, should be on the top there. So now we're going to use this and the point that we need to pass through to create an equation for the line that will be perpendicular to Meadowway. So if we want to be perpendicular, then we're going to have our point slope form, y minus the y coordinate from the point that we are passing through, which in this case, that would be a 3. So I have y minus 3. Continuing with our point slope form, we have equals our slope. Now remember, for a perpendicular line, we need the negative reciprocal of slope. So to do that, we need to take this, flip the fraction, and then negate it. So a positive 1/5 for slope is going to be a negative 5 for our negative reciprocal of slope. So we have that we're going to multiply by x minus the x coordinate from our point up here, which was 4. So now we need to convert this to slope-intercept form. We're going to go ahead and distribute that -5. So I have y minus 3 is equal to -5x plus 20. To get y by itself, we're going to add 3 to each side. So I have y is equal to -5x plus 23. Now find the other one, which is going to be parallel to North Road. So if we're doing parallel to North Road, we're again going to be starting with point slope form. So y minus the y coordinate from the point we're passing through, which, oh, you can't see, but that's right here, that 4, 3. So that's y minus 3. And that is equal to, for parallel, we need the same slope. Oh, but we forgot to get our slope. So now we're going to go back to North Road, and we're going to find the slope of North Road. So we're again going to find a point that crosses directly on a grid line, then find a second point that crosses directly on a grid line, figure out how far we travel vertically and horizontally. We went over 1 and down 1, 2, 3, 4. Because we went down 4 and over 1, that means that our slope is equal to -4. So when we're finding this equation for the line, our slope for parallel will be the same, so we have a slope of -4. Now we'll continue with our equation. So we have slope times x minus x1. The x from our coordinate point that we're passing through was 4. So now we need to convert this to slope-intercept form. We're going to start by distributing that -4. So we have y minus 3 is equal to -4x. -4 times -4, that's a positive 16.
When I recorded this video, I initially said to subtract 3 from each side, but you really should have been adding 3 to each side, which means your second equation should have been y is equal to -4x plus 19, meaning your two equations are y is equal to -5x plus 23 or y is equal to -4x plus 19.
We are going to now go ahead and glue this into our notebooks. So just like before, you can pause this video, take a moment, and glue your word problem into the next page of your notebook. Once you have it glued in, you can go ahead and press play to resume this video. The homework for this lesson is in the textbook. That'd be in section 2-4. You're looking for the practice and problem solving questions. You are specifically doing numbers 10 through 12. You're doing 15 through 27 odds. And you are doing 30 through 33. Okay. That is all for this section. If you have any questions, you can send me an email and I'll get back to you as soon as I can.